Hey guys, welcome back. This is probably the last video for topic 9, and this is dealing with two different topics. This is a continuation of distance, rate, and time, and a new section that we'll go over after we finish distance, rate, and time. So last video, I talked about the most difficult distance, rate problem you'll encounter this semester, and it's this problem. A boat glides downstream for 28 hours. Because of the stream's current, it takes the boat 40 hours to go back upstream. If the speed of the river is 3 miles per hour, find the speed of the boat in still water. So in this type of questions, we're going to assume that the speed of the boat is constant whether it goes upstream and or downstream. Okay? So they're the same thing. So before we visualize the chart, before we fill in the chart, let's visualize the problem. So imagine this is the boat and it's going downstream. This is the first scenario, the bottom part is the first scenario. As you can see, the speed is the same. The flow of the stream is the same, right? So let's fill in the things we know right now. Well, we know downstream goes for 28 hours. Going upstream costs us 40 hours. Now again, since we assume the boat's speed of the boat doesn't changes, what is that thing? What if the boat doesn't change? The speed of the speed of the boat doesn't change. Why do we get two different times? Why is that? Is there something else that affects our speed? Let's look at the graph. Is there something else right here that affects the boat's speed? Yes, and that's the what? The flow of the stream, the speed of the stream. So you can either speed it up when you're going downstream, or you can slow it down when you're going upstream. And what's the speed of the current of the stream? Three miles per hour. So that means the boat can either go faster by 3 miles per hour, or it can go slower than 3 miles per hour. Okay, you guys see it? Because this one is helping downstream, the flow of the stream is helping the flow downstream. The boat is getting faster. If think another way of thinking this is, think you're driving a car, right? And you're going downhill. If you press the gas, the car moves. Like if you just tap the gas pedal, the car moves faster than normally in a flat surface, in a flat road, right? When you're going down a hill, if you just tap the gas, your car is just flying out of, it's just flying already. But if you go ups, if you go the other way, if you're going up the hill, you have to press the gas harder just to move like a bit slow. Am I correct? So this is the same thing with that, but instead of the gravity helping you in the scenario, is the flow of the stream helping you in this problem. If that even confuse you more, sorry. But think think of this let's think of this scenario, okay? Let's look at this graph and hopefully you'll get it if you didn't get my previous example. So now we had to indicate the boat is either going faster by 3 miles or getting slower by 3 miles per hour in the chart. So how do we do that? Well, it's right here. So we're going to indicate the speed of the boat as x. X, again, because the boat speed of the boat is constant, the boat going to be x's, but we're going to add 3 or minus 3 depending whether it's downstream or upstream. And in this case, that's total distance, total rate, total time. Do we ever have total time or total something? No, so we can just cross it out. Now we can find the distance. So how do we find the distance? It's going to be rate times time, which is shown as this part of the chart. Now, like the distance problem, like the school problem, they're traveling the same stream, okay? They're not going to another stream and then traveling that stream. They're traveling the same stream. They're traveling the same distance, right? So that means whether you're going downstream or upstream, the distance has to be the same. So that means x plus 3 times 28 has to be equal to x minus 3 times 40. Yeah, as shown here, this one's a bit cleared up. We kind of moved the 28 in the front and then we moved the 40 in the front in this part, but they're basically the same thing. Now what do we do? Well, we're going to solve for x. First thing first, distribute 28 on the left hand side and you're going to get 28x plus 84. And now let's move on to the right hand side. Let's distribute 40 to both x and 3 and you're going to get 40x minus 120. Now what do we do when we have two variables on either side? We just eliminate the smaller variable. How? We subtract. Subtract both sides by 28x and you're going to get 84 is equal to 12x. Let me draw a line there. So put a 3. And you're going to get 84 is equal to 12x minus 120. Now before we move on, before we do anything else, don't forget to draw the line. And let's move the constant. Again, our goal is to eliminate, to isolate x. So we have to eliminate, excuse me, all the numbers on the right hand side. To do that, we have to get rid of that 120. How? We add 120 on both sides and you're going to get 204 is equal to 12x. Now we want to get rid of that 12. How so? By dividing both sides by 12 and you're going to get 17 is equal to x. So let's interpret the data. So that means x is equal to 17 miles per hour, the speed of the boat in still water. In some questions, it's different types of different variation of this problem. Sometimes you're not given the speed of the current, but you're given the speed of the boat. And what you do is you basically do the same thing, but instead of x plus 3 is going to be the speed of the boat plus x, and then speed of the boat minus x. But the same stuff applies, okay? I don't think you guys are gonna be given questions where neither the speed of the boat or the speed of the current is given, and then the speed, the distance between upstream and downstream. I don't think you guys are gonna be given that. But just in case, I see it in the test, I'll upload another video talking about that. But hopefully there's nothing, I believe. Now let's go, since we're done with the distance, rate, and time problems, let's move on to the final one. Final topic for the final section for topic 9, area and circumference. So area should be similar to you, but some of you might not know what circumference is. Well, circumference is some kind of relationship with circle. So you can think of circumference as perimeter for circles. That's basically it. They're perimeters for circles. They're the distance around a circle. So how do we find it? Well, there's no easy way to, there's no arithmetic way, brute force way where we're just going to add all the sides like when we're finding perimeter of a polygon. And finding the circumference of a circle, we have to use a formula. That formula is C is equal to 2 pi r. This symbol right here is called a pi. C is circumference and r is radius. And then for area, it's going to be pi r squared, where a is area and r is radius. So you guys don't have to memorize these two formulas. When you get your questions regarding areas and circumference, this will be given to you, so you don't need to memorize it. And in this class, at least, we're not going to treat pi, again this is pi, as 3.14. We're just going to treat it as another variable. Okay, we're not going to multiply 2 times pi, whatever the value is. The value is 3.14, but we're just going to keep it as pi and then times r. So what do I mean by that? So let's have an example. So let's say we have a circle of radius 3 meters. We're going to find the area of circumference. Again, it's going to be given to you. So what we're going to do is we're just going to plug in 3 to r. So let's start with circumference. Circumference is 2 pi r. It's going to change to 2 pi times 3. And then what we're going to do is multiply the numbers. 2 times 3 is 6. And we're just going to keep pi as is. So it's going to be 6 pi meters. That's it. That's all you do. No need to multiply 3.14. Just leave pi alone. Now let's move to area. Area is pi r squared, right? And then we're just going to apply 3 to r, and it's going to be pi r squared. R squared is basically what? 9. So it's going to be 9 pi square meters, or 9 pi meters, then with the 2 on the top. Now, this is not really the main topic. The main topic for this is pretty short, but what if we're going to use the circle? How do we find circumference given that we know the area, but we don't know the radius? So this is the main question for in your test, finding circumference from the area. So let's say the area of a circle is 81 pi inch squared. The question is, find the circumference of the circle. From the question, we know that 81 pi is equal to pi r squared. Where did we get pi r squared? Well, it's right here. Area is pi r squared. So 81 pi is equal to pi r squared. Now what we're going to do is we're going to solve for pi. We're going to solve for r. How do we do that? Well, we need to get rid of that pi. So how do we do that? It's a coefficient. Coefficient, how do we mostly get rid of coefficients? We divide. Divide both sides by pi. This cancels out, and you're going to be 81 is equal to r squared. Now what is r squared of 81? Again, some of you guys do this differently. Some of you do the square roots. Some of you guys just know it. So I don't want to get confuse you guys. So what number do we square to get 81? 9. So we're going to use r is equal to 9 to find the circumference. And how do we find the circumference? It's right here. We're just going to plug in r. So c is equal to 2 pi r becomes 2 pi times 9. Multiply the things we can, and you're going to get 18 pi inches. And that's all you do. This is pretty much the last part of topic 9. Good luck on your test. Forget that part. This slide is too difficult. I mean, too hard to explain. And I don't think that question will appear on your test. So, no need to that. Unless it did, then I need to explain it. But we'll cross the river when we get there. So that's it. Thanks for watching. Goodbye.